According to the UN Climate Change Report, climate change could become irreversible by 2030, and urgent action is needed to avoid the catastrophic effects. The focus of our project this year was regarding the expected changes to productive farmland due to climate change. Whether it's through patterns of drought, flooding, or temperature, environmental changes can impact crop performance in drastic ways. A few more specific agricultural impacts due to climate change are soil degradation, shifts in growing seasons, increase in extreme weather events, water scarcity, and displacement of agricultural zones. At Bayer Crop Sciences Plant Breeding Division, the aim is to assess how different germplasms fare under diverse climate scenarios, using a combination of genetic, physical, climatic, and environmental data obtained through large-scale field experiments across hundreds of locations. Insights on climate suitability can inform seed product development and testing operations at Bayer.
This type of analysis is essential so we can adapt and make developmental changes. This helps our preparedness and our ability to support global food security in a constantly transitioning world. There are many factors that we could have an impact on crop yields as time goes on. In fact, there were thousands of different variables regarding genetics, environment, and weather that all contributed to yield of corn. Not all these variables significantly affect how corn has changed over time. We use a tool called Principal Component Analysis to identify which variables are most important to the yearly trend of corn. We then removed all the variables from the dataset that were not part of this more significant group. This way, our data is cut down, making our model more efficient and less time consuming to run, without losing anything that contributes to our regression. We also use a separate model called Optuna that is designed to determine specific parameters for our model to run our dataset with. After running several trials with Optuna, we narrowed down the set of parameters that would make our model fit for our dataset. This way, our model is not only efficient but also leads to a more accurate model to run our predictions with.
Using the trained models with the weather conditions, we gathered the mean yield for various counties in the Midwest. We mapped the mean yield in bushels per acre for corn for the following 5 projection data sets: 2040, 2050, 2070, 2080, and 2090. From the heat maps, the most yield moves from North Dakota and Michigan in 2040 to Indiana, Ohio in 2090. Between 2040 and 2090, agricultural developments such as genetic changes promote a significant increase in harvested amounts. Improved data analytics and sustainable methods help to increase production. By 2090, these trends predict a significant increase in mean harvested amounts. To conclude, due to weather and patterns, the Great Lakes region will possibly become more favorable on average. In contrast, the Great Plains regions such as Iowa and Kansas may become less favorable due to scarcity of water or drought.